What if the next technological revolution isn't driven by faster chips, but by robots that can learn on their own? In China, this idea has been embraced by a wave of ambitious startups. It is estimated that around 50 to 60 firms across the country are competing to develop humanoid robots. China's manufacturing prowess and government support are being leveraged to advance these machines beyond rigid programming into genuine adaptability. The emphasis has shifted from simply constructing machines to guiding them to exist, move, and adjust within human environments. Meet EngineAI's PM-01, a humanoid that doesn't follow a fixed set of instructions. Instead, it observes human instructors, mirrors their movements, and fine-tunes its behavior over time. In practice, PM-01 can pick up complex skills by watching demonstrations, replicating motions, balancing its posture, and calibrating its timing. But it's not flawless. With only a 2-hour battery life and another 2 hours required to recharge, real-world deployments still face hurdles. Each new ability PM-01 masters, however, brings us closer to robots that truly grasp the environments we inhabit. You probably know China as the world's factory, but it's also the fastest-growing robot powerhouse. By 2023, China had 470 industrial robots per 10,000 manufacturing workers, surpassed only by South Korea's 1,012 robots. Germany followed with 429, and the United States had 295. In just 4 years, China more than doubled its robot density, shifting from labor-intensive production toward highly automated facilities. Meanwhile, Japan's growth has slowed, and Germany faces rising energy costs and an aging workforce that's harder to replace with machines. These numbers didn't happen by accident. Made in China 2025 poured more than 1 trillion yuan, about $138 billion, into robotics, AI, and advanced manufacturing, all with the goal of making China self-sufficient by 2025.
Such as electric cars, telecommunications, robotics, and artificial intelligence systems.
Then, in March 2021, Beijing rolled out its 14th five-year plan for the robot industry. That roadmap calls for doubling China's robot density and tripling annual revenue for the sector by 2025, with a heavy emphasis on human-robot collaboration. Today, local governments in provinces like Guangdong and Zhejiang bankroll R&D grants, tax incentives, and startup incubators to keep those targets on track. But what happens to the factory workers displaced by this surge of automation? Millions of jobs in central China's manufacturing belt could be at risk within the next 5 years. To soften the impact, retraining programs have been launched, from vocational schools offering robot operator certificates to subsidies that help factories train employees on digitized machinery. Critics worry these efforts won't keep pace with rapid automation, especially in rural regions where alternative employment is scarce. The question looms large: can policy keep up with technology fast enough to prevent mass unemployment? China is pushing forward, but it's far from the only player. In California, Tesla's Optimus project plans to leverage the same AI chips that power self-driving cars, aiming to mass-produce humanoids for homes and factories. In South Korea, the newly formed K-Humanoid Alliance, backed by LG and Hyundai, aims to launch a made-in-Korea general-purpose humanoid by 2027, with a special focus on disaster response and hospitality. Each region brings its own strengths: California's hardware prowess, China's cost optimization, Europe's ethics-minded approach. But they are all racing toward the same finish line: robots that can safely navigate messy, human-centric environments. How big could this get? Citigroup projects the global humanoid robotics market will top $7 trillion by 2050, driven by an estimated 648 million units deployed across healthcare, manufacturing, and home assistance. But not everyone is that rosy. Morgan Stanley's more conservative models peg the 2050 market around $5 trillion, with the US alone accounting for about $3 trillion, citing slower corporate adoption and regulatory snags. Both forecasts assume steep cost declines. Think PM01 dropping from roughly $12,000 today to under $5,000 by 2030, along with widespread 5G infrastructure and supportive labor policies. If any of those assumptions falter, the road to a multi-trillion-dollar market could stretch out even longer. China has driven down joint costs by 90% in just 2 years by assembling actuators, sensors, and controllers in-country. Yet, when it comes to high-performance AI chips like NVIDIA's H100 and advanced electronic design tools, China still relies heavily on US suppliers. Recent US export controls on electronic design automation software and AI-grade GPUs risk slowing next-generation humanoid development, forcing firms to either innovate domestically or settle for older chip generations. Analysts caution that while China's semiconductor self-sufficiency is improving, it could take 2 to 3 years before homegrown AI chips match US performance, potentially delaying the wider rollout of capable humanoids. Robots are leaving the labs and stepping onto factory floors, into hospitals, and inside our homes. They force us to rethink what work means, how we guard our privacy, and where humans fit in a world filled with intelligent machines. So ask yourself, will you be the engineer refining AI vision algorithms, the policymaker sculpting retraining programs, or the ethicist designing guardrails for human-robot interactions? Because in a future where machines learn like us, staying human might be our most important and most elusive task.